Hi, Steve, KB3ORG, and welcome to This Old Ham Shack. With all the stay-at-home orders and social distancing this year for field day, a lot of people were talking about battery boxes to work from home. Well, the one that got a lot of talk was the Goal Zero Yeti 400, which is a 400 watt-hour battery that has battery box that has some AC outlets, cigarette plug with 12 volt lighter, and some USB chargers. The problem is this thing costs $450. It's a lot of cash for a battery and mostly an inverter. So today I'm going to show you how I built almost the same exact thing for a fraction of the cost. So continue to watch and I'll show you how we did it. This Old Ham Shack is brought to you by bunkerstuff.com. They carry a full line of customizable and personalized items for the ham radio, storm chasing, fire, and EMS communities. Be sure to visit their website at bunkerstuff.com. Hi, I'm Steve, KB3ORG, and welcome to This Old Ham Shack. Okay, so it's the middle of May, and most of us are all stuck at home with the stay-at-home orders, and it's thrown a lot of clubs into a turmoil over what to do for field day. A lot of them are canceling field day. Our club canceled field day, and a lot of members are just going to be running from their QTH, which is forcing them to use emergency power or battery backup if they want to gain points with the league, or just run as a D Delta for just for the fun of it, but you can't get any points that way. Those who want to get points and don't have any way to do any generators at home have been talking about using battery power. And one of the things that's been getting a lot of talk is the Goal Zero Yeti 400, which is a 400 watt battery box. Has an inverter in it, so you can run some AC. It's got a 12 volt outlet. It's got some USB outlets. It's also got some inputs for solar. And it's pretty compact, but this thing costs $450. That's quite a bit of money. So I started thinking, this thing is basically just a battery, which is a 33 amp hour battery with an inverter in it. So I thought we can do that. So I went out and got some parts, and this only has two AC outlets, or has two AC outlets. It has one 12 volt and two USB. What I decided to do is I went out to Lowe's and I found this. Now, yes, I know it's much bigger than the Goal Zero, but I wanted to use stuff that anybody can easily get. And there's also an advantage to this size box, which I'll go into a little later. Now, on this one side here, which is actually the back of the box, here's the front, but the back is nice and flat, which means it's going to be able to house all our outlets and our ports and our switches and everything we need. Let me put this out of the way so you can see. Now ours, the one we're going to make, if you see here, there's a little fancy little LCD which is made just for them, and it shows not only what the battery's putting out, or the battery box is putting out, but it's also showing what's coming into it if it's attached to a solar cell or a solar panel, which ours will be able to do. So in order to get around that, I had to we're going to be using two displays. One's going to be for what the battery's putting out, so you can see what's left to it, and the other is going to tell us what the solar power is putting in. We're going to have two 12 volt ports or cigarette lighters. We're going to have two ports for USB, but each one of these houses, I don't know if you can see that, it houses two outlets, so we'll actually be able to get 2.1 amps. We'll be able to have 4 gadgets charging. On the side of the unit, we're going to put in a 2-port power pole, so anybody who wants to do anything with Anderson power poles will be able to do that. And of course, you can't forget this. It's going to have 2 AC outlets. Now, I was able to read a lot up on the Goal Zero. Everybody seems to like them. I'll bet a bit pricey. But one of the problems they noticed were, here's the 2 AC outlets. So if you have 2 wall warts that need to plug in, they can't go to next each other, because once you plug the one wall wart in, it blocks the other AC outlet. So what we're going to do on ours is we're going to place them at opposite sides, so we'll take care of that problem. So, we also forgot the main thing to show you. The inverter. Actually, the most important part is the battery. It's a 12 volt, 33 amp hour battery, which gives us 396 watt hours. Got this from Harbor Freight, 400 watts nominal, 800 watts peak. It has 2 AC outlets, 2 USB ports. The USB ports we're not worried about because we have them covered in the battery box. The AC outlets, we're going to extend those out to the outlets that are going to be on the box. So that's small compact unit, fit right in there. So those are all the parts. The only thing left to do now is to start getting the box ready, which we're going to do by cutting out all the holes for the ports and the displays and the outlets and switches. So that's what we're going to do next. So here we go. Okay, the first thing we're going to do is we're going to put some painter's tape down. It's going to allow us to draw where everything needs to be. Okay, so we have the painter's tape down. Now we have a nice area that we can mark up where the holes have to go. I've made this a template out of paper where everything has to go. Line this up, and we'll use an awl on the square pieces here, here, here. Now what we'll do is we'll lift this up. It's hard for you to see, but there's points where all these are, and now we'll make the lines that join them. Okay, I don't know if you guys can see that or not. Got all the lines in there, and now we will cut them out. Okay, now these have to be drilled. So now we'll go get the drill and we'll do that. Okay, all the holes are now drilled out. Your 12 volt, USB, AC, 2 monitors, power switch, and this is a switch we have here that's going to turn the battery monitor on and off, because this can serve some of your electricity, your DC volts. We don't want that monitor always on, so this way you can turn it on and off as you want. Okay, so what we're going to do now is make a hole on the side right in here so the fan can fit in there. And as luck would have it, there are 2 sides right here to hold, right here and right here, to hold the fan in. There's a notch at the bottom, so what we're going to do is drill holes in there for the mounting screws. Okay, so there's the 4 holes to mount the fan. I still have to draw a circle here so the air can get out. So we're going to put some tape on here so we can make our lines to find out the center, and then we'll drill the hole. Okay, that should roughly be the center. So we'll get our hole saw. And to make sure the drill bit doesn't wander, we're going to start with little drills. Drill a little hole, then a big hole. All right, next size up. That should make a good pilot hole for the hole saw. There we go. That'll be the fan. I might put a grate or a screen cover on top in front of that. Might have to 3D print that. There might be another way to do it, but it's always fun to 3D print. And now we're going to start putting all our ports and switches in. The inverter switch. Now, these are the 2 meters that are going to be going in here, respectively, but they have very small connectors right back here, terminal connectors, and right back here, and I think I'm going to leave them out until I'm ready to wire them up, so I'm not trying to eye them up inside this small space. This also is the Anderson power pole socket, which is going to go right here on the side. Again, I still have to put the Anderson, it's empty. I have to put the Anderson power poles in there, so I'll do that later as well, and then I'll put this in here. Well, at this point, you're ready to do some wiring, so here we go. Okay, so all the wiring is done. I've hooked up the connectors for the inverter, which we're going to do next. The battery status display is all hooked up. So we just need to take these cables and attach them to the inverter. Okay, so now the inverter is all hooked up, and if we hit the switch on the front, it should turn the inverter on with those sparks. Okay, we have power on the LED. So far so good. Let's turn that back off. Internal battery power off. Now we'll hook up the actual AC outlets. Okay, so we're hooking up the AC outlets. And one of the things I discovered were that the tabs, let me see if I can get them, for the spade connectors, they're actually pretty thin, and the spade connectors don't stay attached very well. So what I ended up doing was soldering on the wires and then connectors. So now we're going to put them onto here. Now we'll do the other side. Now we just need to put in the display port for the charging system. That's the system all powered up with the display. Okay, for the exhaust fan that we're going to put inside on the side here, turn this around so you can see. I was going to hook it direct up to the 12 volt that powers the inverter, so it's only on when the inverter is on. I'm still going to do that, but I found these on Amazon. I think they were like $3 a piece, and it's a fan controller board, which means it'll control the speed of the fan based on the temperature. There's a little temperature probe right here. Let's see if I can get this board close to you. Okay, there's different dip switches on here for settings for different temperature ranges for what it's going to do. I'm just going to use the defaults. So we're going to power this up now, and let's see what happens. Okay, so we got the board all wired up, and let's see how this works. Okay, so the fan is running, blowing out, nice and quiet. All right, so now we're going to go ahead and we'll mount this into here. So all we got left to do is put the cooling fan in with the fan controller board that we talked about earlier. Here's the speaker that sounds an alarm if it goes out of range. This little wire here, let's see if I can turn this around so you can see it. That's the temperature probe that catches the temperature. There's a little tip on there. All right, so we're going to hook the fan up. It's got a spot for 3 fans. We only need 1 of them. And in the background there you can see my mascots, my turtles. Alright, so this just slides right into here. And remember we talked about putting a grill over here to protect so you can't put your fingers in there. Originally I was going to 3D print something like that, but I figured what would be quicker and easier is if I just did something on the laser cutter. So I printed that up. Okay, there's the fan. What we'll do is we'll turn the inverter on here, and you'll see the fan will kick on, putting out a nice amount of air. That'll keep it cool. So that pretty much finishes this project up. I'll show you exactly what we've got. Works 12-volt system. That works the meter, and of course that is the inverter. The inverter is running. You can hear the fan going. And what we'll do is we'll do some tests on it now to make sure everything's running right. Okay, so we'll do some tests here. This is a USB tester. And as you can see, it fires up 5.1 volts. So that means we can charge our items, such as phones and tablets, when we're out in the field. Okay, test 12 volt. I'm going to put, this is what I use for charging some of my battery boxes. I'm going to plug this into here. And you can tell we pretty much have power because there's already a red light there. But just to make sure, here, 12.8 volts. Okay, so I want to show you the power meter right now. We'll power on the box. And we'll come over here. As you can see, it's reading 12.8 volts, was what we got on the voltmeter when we did the cigarette plug connections. And now we're going to turn the inverter on. But I was going to use a radio to plug into here, but usually if you use a radio, you go right to the 12 volt in practical on field. So what we're going to do is I've got a small fan here, which you would use out in field day or any time you're out in the park or a tent. So what we're going to do is we're going to turn the inverter off. We're going to plug it in, turn the inverter on, and there you go. I guess you can see the fan is running. There it is, running on high. I'll back it down to here, and now let's show you the power meter. All right, our volts dipped down to 12.5, and we're pulling about 3 amps, okay, and about 38 watts now off of the battery to power the inverter to get this fan going. Okay, let's summarize this project. With the case we got from Lowe's, yes, it's a little bigger than the Yeti 400, but there's an advantage, and we're going to go over that in a second. We have on the front panel 2 USB ports here and here for a total of 4, 2 12-volt power ports or cigarette lighter plugs, whatever you want to call them. We have the main 12-volt power supply, and we have a meter to tell you what the performance of the battery is, how much voltage is left. The meter over here, which is not hooked up yet, which is for the solar panel. That'll be another video. We actually add a solar panel to this so we can see that performance. The 2 AC outlets, which we showed earlier, work real great. Okay. Anderson power pole on the side, and the exhaust fan for heat over here, which is speed controlled based on the heat. Now, we keep talking about how much bigger this is than the actual Goal Zero Yeti. Okay, but the advantage of this is there's so much room in here. Right now this is a 33 amp hour battery, which gives you 496 watt hours. But if you put another battery in here, which there's plenty of room with, and you hook it up in series, okay, or I'm sorry, in parallel, that's going to give you almost close to 800 amp hours. It's a little heavy, but not that you can't carry it. 800 amp watt hours, okay? So that's pretty substantial and an advantage over the Yeti. Now, next, let's break down what the cost of this is going to be. All right, here's a spreadsheet of all the parts that I used and the cost. The total came to $173. You got to add in a few more dollars for the wiring and the connectors and miscellaneous parts like that, but that's not a whole lot. The Goal Zero Yeti 400 comes in at about $450 on Amazon. Our project only cost us $173, so that's a savings of $277. Even if you bought another battery to bring it up to 800 watt hours, you're still saving over $200 over the Yeti 400. And there, like we said, there are some advantages over what we made to the Yeti 400. All in all, I'm very happy with this project. Between finishing this project and starting it, I actually did take this out to field day, and it actually did help me, as I had some noise on my generator, and using the inverter in this box, I had no noise on the radio at all. So I was able to help, eliminate and figure out exactly what that interference is. Okay, so that concludes this project for today on this old ham shack. I hope you enjoyed it. If you have any questions, just leave your comments below, and I'll try and answer them as quick as I can. I know I went over some things rather quickly, but I didn't want to drag this out too long and bore you guys. I'll have links down below to all the items that we used. So if you have any questions, feel free to put your comments and questions below. If you like this project and you like what you see, hit subscribe so you can follow me. And drop me some notes and hit the bell so you know when things come out, and let me know what projects you'd like to see. Until next time, this is Steve, KB3ORG, for This Old Ham Shack.